Hello engineers, welcome back. In the previous videos, we learned some array techniques like two pointers and sliding window. In this video, we're going to learn another technique called the prefix sum. Let's get started. So in this video, we're going to see what is a prefix sum and we'll see when to use it. Okay. So to understand the prefix sum, let's take an example of an array. Let's say we have an array like this, a simple array with 5 elements, 10, 20, 30, 40, and 50. Let's say I want to find the sum of first 3 elements. So how would we naturally do it? We will start a for loop at 0. We will go all the way up to 3. And we will keep a sum variable at 0. And we would do sum plus equals a of I. And we will get the result for the first 3 elements. Let's say we want to get it for the first 4 elements. We would have to repeat this loop and run it all the way up to 4, and then we will get the new sum. If we want to do something in between, like first to third, then we will have to start the loop at a different pointer, end the loop at a different number, and then we'll have to do the sum. So every time we want to do a sum, we are doing a different kind of loop and we are iterating over the array multiple times, right? And that is not very good. So we can make use of something called a prefix sum to enable us to not iterate over the array so many times. So when we are dealing with an application that requires something like checking the sum of different variables in different elements inside the array multiple times, many times, then we can probably make use of something called a prefix sum. So how does this look like? So if we have this array A with 10, 20, 30, 40, 50, we would create a new array, something called a prefix sum or some other name. And what this contains is the sum of elements up to that point. So the prefix sum will also have the same number of elements. So we have the same indexes, and prefix sum of 0 will have the sum of elements up to 0. So the number of elements up to 0 is just 10, so we will just have 10 here. But when we go to 1, it will be the sum of elements up to first element in the main array. So it will be the sum of first two numbers, 10 plus 20, and we will have 30 here. And when we want to see the next element, we will add the next element in the array. We will get 30, 40, 50, 60 in the prefix sum. And this goes on. So what will be the next element in the array? We will add 40 to this and we will get 100. And the fifth one will be 150. So we make use of prefix sum. We ask for additional space. So we are requesting some additional space so that we can make use of prefix sum to answer these kind of questions. So let's say now I want to ask what is the sum of elements between 0 and 2, and I simply need to go here and get the value at index 2. Now we have 60. So can we verify it? So we can verify here 10 plus 20 plus 30, we have 60. Now why would we do this? So if we had to do this in our previous way, we would have to run n operations, right? Imagine when we are requesting for the last element, we would have probably used n operations. But here it is a direct lookup. So I can just say prefix sum of 2 and it will give me 60. This is one operation. This is a direct operation. So by creating a prefix sum once, so in order to create this prefix sum, we will use n operations. But once this is created, we can make use of this array now to answer all kinds of queries with respect to sum between the elements, right? If I want to ask what is the sum between first element till the last element, I don't have to recalculate again. I can simply call the index on the last element and I will get 150. And this is a single operation. This is constant time, right? So that's why prefix sum is used. So whenever we see questions based on ranges, so we saw what is prefix sum. So When do we use it? We use it when we have range-based queries. When we want to answer range-based queries. So within the array, we are looking at some range in between and we want to answer those elements. So that's when we use prefix sum. So how do we build a prefix sum? In code, we will directly go to VS Code and start coding it. It's a straightforward method. Let's see. So let's create a new file today. Let's call it prefix sum. And let's get our template. Let's call our main function and we are good. So let's use a vector. So if we are using a vector, we need to call the vector package. We need to import it. And we are using integer vector v. And let's push some elements into it. 10, 20, 30, 40, and 50. Now, in order to make a prefix sum array, let's use another vector, and that will also be int, and let's call it prefix sum. So how will we fill these values? So we will iterate over the first vector. Int I equal to 0, I less than v dot size and I plus plus. And because we know the sum of the first element, we can directly initialize the first element. So we can say prefix sum dot push back v of 0. So we know the first element in the main vector, and this will be the sum of first element, right? So this is at the 0th index. So 10 is pushed back into the prefix sum array. Now prefix sum is looking like something like this. 10. This is the first element. And we need to keep adding elements to it. So how do we do that? We say prefix sum dot push back. Now here we need to get the sum up to the previous point. So how do we do it? We need the value that is available in the previous value of prefix sum. So we can do something like this, I minus 1, and we just need to add the current value from the main vector. So v of I. That's it. Now here in this case, I minus 1 will return an out of bound error. So we can start I at 1 because we already calculated the sum of the first element. So we start at 1, we get the previous element, I minus 1 becomes 0, we get the previous element of prefix sum, which is 10, and now we are getting the first element from the main vector, which is 20, and we add these two and push it back to the prefix sum. Now prefix sum will have 20, loop will continue, we have 30, 40, sorry, this will become 10 plus 20, 30, and then we'll get 60, and then 100, and then 150. So this is what we should see. So let's print it out. Let's iterate over the prefix sum vector this time, and let's print it out. Int j equal to 0, j less than prefix sum dot size. We are iterating over the prefix vector now, and j plus plus. So see out prefix sum of j in line. So I think that's it. Let's see if we have done everything correctly. And here is the output: 10, 30, 60, 100, 150. So we now have the prefix sum. So how do we use this? So if I want to get the sum of first three elements of the main vector, so I can simply query n minus 1. So sum of first three elements. So I can do cout and quote it. And here I can directly call prefix sum of 2, and that's it. Let's run it. And we get it. So as you can see, this is a constant operation. We have not iterated over the loop again. So first time when we are building the main prefix sum, we have iterated over the array and we got our prefix sum. This is making use of extra space. So this adds some space complexity, but it is helping us in the long run because we are able to do queries on all the elements. Something like this. First 3 elements, first 4 elements, first 5 elements, and we get it in constant time. Okay, we could also get the range. So if I want to say sum of elements from second index to fourth index, so how would we get that? Second index to fourth index. So second index is 0, 1, 2 here, and fourth index is here. So I need the sum of these three numbers: 30 plus 40, 70 plus 50, 120. So I need to return 120. So how would I do this? So I simply do a range query on the prefix sum. So what would I do? I need to do something like this. So cout. So let's get the result first. So let's call it result of prefix sum of 4 minus prefix sum of 1. Let's see if that logic is correct. Prefix sum of 4 is having 150. 150 minus 1 is having 30, and we get 120. So that is what we needed, right? 50 plus 40, 90, 90 plus 30, 120. So we could do a range query like this, and we can do cout result is result. Let's see. So the result is 120. So we got our answer. So it is very simple. So whenever there is a range, the end, the last element in the range is something we pick as it is, and the first element we do n minus 1. So if this was m comma n, we are doing prefix of n and prefix of m minus 1. That's all we are doing, because if you look at it, we need the sum of these three. So we have eliminated these two from the from our range. So that's how we get our desired answer. Okay, so you can test this with different examples and you can find out. So that's how we can make use of range queries using prefix sum. Okay, so that is it for this video, guys. I think we have covered the introduction to prefix sum. So if you have any questions, you can definitely ask me. I will see you in the next video. Meanwhile, please don't forget to like the video. Please don't forget to subscribe to the channel. Please bookmark the playlist and do share it with your friends. I will see you in the next one. Thank you. Cheers.